All right, so this is 214, week 9. Tim's working on the whiteboard. I'm going to work it on the bamboo pad. Corey and Dustin are working on their computers too, but I worked this out a little bit last night, so I'll just review it again. So what we're looking at in our pumped storage problem, and what we're looking at here, this is just H, or head in feet, and the formula for calculating head loss is V squared over 2G, and G is just gravity. And what I've tried to show in this depiction of a pipe is that you might have a large velocity down the middle. You're going to have smaller velocities at the edge of the pipe, but overall you're going to have some mean velocity in the middle. So the first question was, how do you get from Q, your flow rate, to V, your velocity? Well, we know that dimensionally the flow rate is going to be in gallons per minute, and so we can write that up here. So gallons per minute, and that's going to be Q. So I've just put the dimensions of Q. Gallons are measured in cubic lengths. There's length cubed up top. Minutes are a unit of time, so I've got time in the bottom. We know that velocity is length per unit time, and the only other variable we have is the area of the pipe. So from that, we can determine that the volumetric flow rate just equals the area times the velocity. Pretty simple, because the area, again, is just L squared. Multiply your L squared by L over T, and you get L cubed over T. All right, so that's pretty straightforward. And then, so once you've got your velocity, you can then calculate your pressure head loss. So to do the conversion, I think, Tim, you're doing it up there. Yeah. Right, so you went from velocity to gallons per minute.
I did gallons per minute to get how many gallons a second.
Gallons per second, yeah.
Then gallons a second times
.008.
how many gallons per
Cubic
foot
foot,
of water divided by pi r squared.
To get your feet per second. Nice. Okay, so basically the same thing. We started out with 140,000 gallons per minute. We know that you just had 0.0068 gallons per cubic foot. Same difference, 7.48 gallons per cubic foot. Convert minutes to seconds, so I came up with 312 cubic feet per second. Ran the same thing divided by area and came up with 15.9 feet per second. Yeah, okay, cool, good. So we're good on that. From there, just came up with the head loss, so we do our V squared, that's 15.9 squared up top, 2 times gravity on the bottom, and
Times 45, because that's per 100 feet.
yeah, so you basically have 3.9 feet of head loss per 100 feet. The pipe is 4,500 feet long.
177, yeah, I came up with 106 or 176 just from the rounding difference.
Yeah. So you probably carried more decimals on that
Yep.
initial one, so. And then we take our 177 feet of head loss, that converts to 75 PSI. We didn't actually need the PSI in the calculation, but there you go.
Yep.
Did you square gravity?
Okay. That's enough to be dangerous on that,
I
on
think
that
so.
first problem. Okay, cool. And then from there, I think we were talking about the fact that you can think of this as an additional efficiency. You know, so your pump or your generator have an efficiency, and this is just an additional loss of efficiency. And so the 177 or 176 over 900 equals 177 divided by 900 equals, so you can think of that as a loss of 20%, or conversely, if you do 900 minus 177 equals 723 divided by 900 equals 80. So
Where's the 900 coming from?
wasn't that the initial
900 feet
head?
ahead.
Initial head?
But aren't we using the 45?
Well, that's the length of the pipe, but the head is the same regardless of the length of the pipe.
So the friction of the pipe, that isn't a function of the length of the pipe, it's the function of the head?
The friction is a function of the length of the pipe. And think of it this way.
Which is 40.
Yeah.
400, right?
Well, yeah, but think of it this way. You could have a pipe sitting here horizontally, and you're gonna pump through there at some velocity. You're gonna lose pressure pumping horizontally, and there's no head in there at all. It's all the same pressure. Same thing though. You're gonna pump vertically, 4,500 feet at some velocity. It's going to still cost you to pump it, whether you're pumping it up or sideways. In the case of this horizontal guy, you're not getting any stored power out of it. You're just sloshing water around. But the other point is, think of some other system where it's somewhere in between the two. In either case, so right here, your head equals 0, head equals, just call it max. And right here, your head is greater than 0 but less than max. So the head is just the difference between the top of the pipe and the bottom.
So what you're saying is, for this, that's past this last scenario that you said is between 0 and between max, what happens if it's at that same angle but it's equal to max? That doesn't change anything?
Well, yeah, what happens is your pipe's going to get longer, right? So if you're trying to get 900 feet out of this guy, pipe's going to get longer, and you're going to lose more pumping.
Well, that's what we're doing,
Yeah,
right?
Yeah.
So I was just confused why you're using 900 instead of 4,500.
Oh, the reason is because the change in elevation is 900 feet. It might have.
You've already used your 4,500 in your calculations for your head.
Okay.
You can just think of it as Pythagoras, right? I mean, here's your 900, here's your 4,500. Right, you're just pumping it up a mountainside instead of straight vertical is the only difference there.
So then that bottom leg, the bottom plane is going to be your, what was it, 177?
Well, no, it's a little.
723.
Actually, no, it's a little more subtle than that.
Right.
No, the 177 is how much pressure loss there is just because there's friction in the pipe.
Okay.
Yeah. It's a delta P because you're, well, I mean, you can even think of it as just a garden hose laying on the ground. There's a whole bunch of pressure at the house, and it's just atmospheric at the end. So you're effectively losing. You get that thing longer and longer, and eventually you're losing all your pressure.
Just falling out.
Yeah, just because of the length of the thing.
Okay.
Okay.
So where are you getting 0.087 for the frictional head? I guess I see where you're getting.
Got your velocity up top squared. And that's divided by 2 times gravity,
Yeah, I got
which is
that.
32.2 times And
Mm.
that's per 100 feet. So you have to figure out, there's 45 of those 100 foots in there. So.
Is that, are you just getting it from 3.9 divided by,
So your bottom number should be 2898.
Bottom number.
So what I did is I took that's .087, and just turned that into a percentage, and then applied it, which is not what you can do.
I'm not getting that decimal.
I don't understand where you're getting the decimal, because you're not timesing anything by 100 feet.
We're times it by
You're not timesing,
45.
you're dividing. Yeah, you're timesing it by